Hello again and welcome back. I hope you enjoyed that panel discussion, and now welcome to this roundtable discussion with Serge Haroche. Again, we have a group of students selected very rigorously from many different regions of Brazil, and it's an absolute joy to see all these faces on screen again. Welcome to you all, and thank you for taking part. And thank you too for the audience for staying with us. This is a long affair. We're coming into our third hour. So for those of you who've been with us throughout, thank you for taking the time to join us today. Right, on with the questions. It's your chance to ask Serge anything you like. So who has the first question? Boxes jumping around. Andressa, please.
Hi, my name is Andressa. It's a pleasure to be here with you, Serge. I'm doing a PhD in biotechnology at Federal University of Alagoas. And my question is, what do you think that we can do to make science more accessible, more understandable to society? I think that we as scientists, we do not speak easily language that society can understood.
Yeah, I think it's an important question because scientists are part of society, and it's clear that we need the trust of society, and society has to understand that science is important, that science has values which go beyond science, because we are trying to show that truth is important, that rational thinking is important, that to find solutions to the problems that mankind is facing, society needs science. And so what I think what should be done, of course, is to have a good education for children, for young people. It has to start with young people. So what I am doing when I can is to go and to talk to elementary school or middle school and high school students, try to explain to them the value of science, give some simple examples, maybe talk about the history of science, because the history of science teaches us a lot of things about the value of science, the way science proceeds, the importance of collaboration between people, the fact that science is universal, that science does not have boundaries and borders. So all these efforts have to be done, of course. And I think it's important that scientists do not remain closed, talking to themselves, that they try to open to society. I understand it's not easy because science is becoming less and less intuitive, and you cannot do science without making efforts to understand things in a deep way. And for example, in physics, it needs mathematical skills, and you cannot, you can use images, you can try to bring children towards science by playing games, but at some point, you need, people need to make an effort to bridge the gap between ordinary knowledge and scientific knowledge. And this effort is, I understand, is difficult, but it's necessary. And we have to, it's not easy, but there are ways to make young people aware that science is important. We have to try to wake up their curiosity, their amazement to the fact that the universe is full of interesting questions, and through that we can bring maybe people to science. There's a lot of science which is appealing to the imagination of people. Astrophysics, the research for exoplanets and life far from Earth. All these are very big questions about life, biology, neurosciences, about the brain, open up to a lot of questions which might appeal to young people if the question are asked in the right way.
Thank you. Antonio, you have a follow-up.
Hi, everyone. Hello, Adam and Professor Haroche. My name is Antonio Capanema. I'm a physics PhD student at the Pontifical Catholic University of Rio de Janeiro. And my question follows exactly the same topic that we were just discussing. I would just like to narrow it down a little bit, I guess, into physics, which is your field and my field. And physics can sometimes seem relatively disconnected from our everyday lives due to its complexity and especially fundamental physics research. My question is, in the same sense, how would you address this issue to the general public, not only to spread scientific literacy, but also to make a case for funding physics researchers?
Yeah, that's a very good question. I think one has to stress the fact that fundamental physics is the background on which applied physics is built up. And you can give a lot of examples, simple examples to the general public, tells them that technologies that they are using in their everyday life without asking any questions about it, in fact, come from fundamental science. I often take the example of the GPS, trying to explain to people that every taxi driver in the world is using the GPS, and the GPS is a marvel which is based on quantum physics, because atomic clocks are based on the laws of quantum physics, and the GPS would not work if it did not incorporate special and general relativity, the fact that the clocks which are orbiting in satellites have a time which elapses at different rate because they are not in the same gravitational field, or they're not at the same speed. And if these corrections were not taken into account, the GPS would be worthless because it will be off by kilometers. So I take this as an example, and you can multiply the examples, and just to show to people that all the technologies which they take for granted come from basic science, and that at the origin of all this, the questions which were asked were curiosity-driven questions. When Einstein developed the theory of relativity, he had no idea that one day there would be a GPS. He did that, and the GPS came after that. And the same is true about the laser, which was also an original idea by Einstein. It took half a century before this came to fruition. So this also illustrates the fact that there is a long time scale, that the science evolves over many, many years. And you have to give this feeling also to people who are not scientists, so that they will understand why you have to fund, why society has to fund research over long periods of time for this to be fruitful.
Thank you very much indeed. Okay, let's go to Fernando.
Hello, I'm Fernando Durria, 24 years old, PhD student from the Federal University of the State of Rio de Janeiro in Rio, researching about artificial intelligence and its interaction with society. My current research is about automatic detection of fake news. Professor Haroche, quantum physics is entangling with computer science lately. How do you think quantum computing will be contributing to the efforts of research in times of crisis like the ones we are living now? I mean, should we expect faster tests, facilitated simulations, or any improvements in research processes?
Yeah, you are asking the general question of the quantum computer, and that's a difficult, it's very difficult to predict what will happen. In fact, as you know, the idea of the quantum computer is to use the strange logic of quantum physics in order to speed up some kind of calculations, to use the fact that a quantum computer would work along many passes at once, and that the answer to the question, the answer to the solution of the algorithm would come from an interference between all these passes. So this is a very nice, very beautiful idea which has been developed over the last 30 or 40 years. The problem is to build a machine, a hardware machine which would implement this. And the problem is decoherence, the fact that the quantum superposition are very fragile, very sensitive to the environment. And if you want a computer to work, you have to be able to protect the system from these perturbations and to develop what is known as quantum error corrections. And all this is subject of a lot of fundamental research now, and there are many candidates for quantum bits working in quantum computers. And for the time being, it remains still a dream. It's not clear how the machine will work. there will be, if the machine works one day, there will be connection with artificial intelligence. But it's quite clear that the quantum algorithm could be used for in the building deep learning algorithms, and this is really the dream. But what makes the research so appealing is that you never know what will happen, and it's very well possible that all the research that is going on today will lead to things that we are not imagining today. And this happened in the past a lot of time, and it's very well possible that the quantum computer will not be what we imagine. There is another line of research, which is quantum simulators, making artificial systems which behave like real systems, but at a different scale. And these quantum simulators could be used to solve some problems that classical computer cannot solve now. And so all this research is very active in the world, and it needs resources, it needs bright people going into this field. But I think the danger is to oversell. If you tell people there will be a quantum computer in 5 years or 10 years from now, and if this does not happen, it will be very bad for the field. So we have to be honest to say that it is still basic science and that we don't know exactly what will happen, but this is fascinating and interesting. And this is the connection between basic science and applied science is a very subtle one. It may take a lot of time. And the example I gave to the previous question, the time it took between general relativity and the GPS was almost 1 century. But you have to build up on all what you know for applications. And what is sure is that applications will come. And it's also sure that if we don't do basic science, then there will be no applied science at all. So we have to go through these stages.
Thank you very much indeed. And that whole question of building up false expectations is very much connected with the questions we were talking about earlier, how to get people in general to value science. But now there are quite a lot of hands waving at me for follow-ups. So let me try and get it right. Victor or Jose, you were wanting to come in now, please.
Thank you, Adam. I'm Victor Silva, PhD candidate in Science and Technology Policy at the University of Campinas, located in the state of São Paulo. My question, Professor Haroche, you emphasize in your book that science needs good instruments, but researchers increasingly point to artificial intelligence as more than a tool. In addition to providing predictive and prescriptive insights, it takes autonomous decisions. So does being an autonomous agent mean that in the near future, it could receive credit for its own scientific discoveries? And how the scientific community would react to this?
I would like to make sure that I understood what you mean is that will artificial intelligence be able to do research by itself and receive funding to do that?
To receive the credit for discoveries, for finding patterns and so on.
I think also the question of whether artificial intelligence will one day get the Nobel Prize, I suppose.
Yeah, so I am very dubious about that. I think artificial intelligence is a way to process enormous amount of data and to do things that would take much more time for human brains to do, but the human brain keeps the freedom to choose the question, to address the issues. And I think and I hope that artificial intelligence will not overcome imagination and the creativity of real people. It's a fantastic tool to help us doing things. For instance, the fact that you can use now artificial intelligence to translate one language into another one is something which was unbelievable only a few years ago and becomes now more and more precise and better. The fact that cars could be driven, would drive themselves alone, and all this is just processing information at a very fast rate. But I don't think that what really involves creativity, imagination and creativity will be possible with that. Maybe I'm mistaken, but I discussed with people who are knowledgeable in artificial intelligence and people who have been working in this field, and they agree with what I am just saying. So I am not working in this field, but I would be very surprised if a machine would overtake the human brain in this respect.
Now, we might revisit these topics in a minute, but I'm just going to jump somewhere else. Ana Luisa, would you want to ask your question, please?
Thanks. I'm Ana Luisa Tiberio, and I'm graduated in law and I'm studying accounting at the University of São Paulo. Science is often associated only with biological and exact sciences. In Brazil, even the humanities area has been the most affected by cut of scholarships and investment. But as a jurist and an accounting student, I do not agree with that. And you, doctor, do you believe social science is also science? How do you believe we from the social science can contribute to national development?
Thank you for the question. I think it's very important. I think culture and civilization is a whole. It's science and social science, philosophy and humanities are going together. And in fact, in the past history, it has been shown that science and social science and humanities in general are part of the same endeavor of humanity. If you start in the 17th century, a philosopher like Descartes was also a physicist, and the development of the scientific method has been linked to philosophical thoughts back in the antiquity, and then during the Renaissance and the years of the Enlightenment also. Free thinking is very important. The fact that freedom of thought and freedom of thinking and of discussing is essential for science to develop. And I think it's very important that a critical mind, the possibility to decide what is right and what is wrong, what is truth and what is lies, is something which comes from a general education, not only science, but all goes together. And I agree that it's very bad that humanities are under funded, and that governments have a tendency to decrease the funding in these fields. It's also very important because people will be politicians and political people who would be in charge of society have to also to understand what science is about. So you have to keep a link between science and humanities if you want to have in charge people who find that the values of science, that the importance of rational thinking is essential. So I think that countries, democratic countries, have this big advantage over countries where there is no freedom, because the mind of people are more open, and there is, I think it's very important for the creativity and for the imagination to be able to flourish. So I really believe that this is important. Even if you are a scientist, you have to understand how your field has evolved over the centuries. And so science cannot be completely disconnected from the history of science, the history of ideas, the history of philosophy. All this goes together.
Thank you very much indeed, Serge. Mariana, may we come to you now?
Hey, good morning, everyone. My name is Mariana Fronza. I am a PhD student in biotechnology at Federal University of Pelotas, representing the state of Rio Grande do Sul. So, Professor Serge, I would like to ask you to follow me and go back in time at the end of the Second War and the death of millions of people. Paul Valery illustrated the thought of the period with the sentence, "We civilizations now know ourselves mortal." What is, in your perspective, the great lesson in science that COVID-19 pandemic leaves for our society?
You made this quotation from Valery is very well known, and of course it followed the Second War and the atomic bomb, which was used at the end of the war, and so we got the feeling at that time that for the first time in history, man has the power to destroy or to affect in a very important way the fate of our planet. And this has happened since in other fields. Before the pandemic, we have the global warming, the fact that we have entered what we can call the Anthropocene, a new era of the planet where the human activities have a very deep impact on the planet. And at the same time, and then you have the pandemics, which are also somewhat related to that because they are linked to the fact that the viruses which were trapped into animals are now going into humankind, because there is the boundary between the animal world and the human world have been somewhat relaxed by the globalization and by the fact that the environment is being destroyed, and all this affects the planet, and this is, I think, this is a big challenge that mankind has to face during the next decades. The fact that we have to do something now, and we have also to take into account that the system has a lot of inertia built in it. So what we do will have an effect only after many years, but we have to, certainly we have to take this into consideration. And the big danger is the fact that we have all these conspiracy theory denials of what's going on, the fact that there are a lot of fake news, the fact that there are people who prefer not to face what is going on because it's disturbing them, and so it's a big problem. And I think the young generation, what your generation has an essential role to play into that. First, to take to understand the issues, and then you have to solve them. And I'm afraid that the older generation is putting a lot of burden on you, because we should have acted before on these issues. It's clear that the situation is difficult, but there are solutions. There are solutions. It's clear that physics and chemistry can bring solution to the energy issue, to the fact that we have to get rid of fossil fuels. It's clear that biology and biotechnologies are essential, and the example of the vaccine, the success in getting vaccines within 1 year is a fantastic illustration of that. And it also illustrates the fact that there is a very deep connection between basic science and applications, and you need, all has to go together. Science is, of course, neutral. Science is neither good nor bad. It gives us knowledge, and then we have to decide what we do with the knowledge. And I think that's what Valery had in mind when he talked about the bomb issue in the 1940s. So it's really, I think, the main challenge that mankind is facing today.
I remember reading in a Feynman article a quote that the same discoveries that open the gates of heaven also open the gates of hell.
Yeah.
It's
yeah. You can think of the internet, which is wonderful for communication, but which also is a nest for all these conspiracy theories.
Pedro, please.
Thank you, Adam. It's a great honor to be here. My name is Pedro Pinheiro Cabral. I study physics at the Federal University of Rio Grande do Norte. And my question for you, Professor Haroche, is during my studies in astrophysics, I learned that the sun has solar storms and that a superstorm could disrupt almost all modern technology we take for granted, as the GPS you mentioned. We could go days without technologies we rely on. So governments and companies such as banks and in the developed world in general have crisis plans for if this happens. I'm now doing a traineeship in a big Brazilian bank and have found that no Brazilian bank or government have plans in place. Executives aren't even aware of the risk. What can we do to make sure governments and companies take science seriously to protect us all from the next disaster, such as a pandemic or solar superstorm?
I think that, first of all, you have to try to evaluate the risk, the probability of the risk. You quoted the risk of solar storms. There is also a risk that at some point the Earth's magnetic field the North Pole, magnetic pole will go to the South Pole, and then this will be a huge disruption in the kind of shield that we have from solar particle showers, and this will have also a terrible effect on all communication. You can also think of an asteroid colliding with the Earth, but the probability of these events to happen in the near future are very small, because these are events which happen on geological scales. What is much more probable is the risk of a new pandemic, because this might accelerate because of the conditions that we see today. And the risk also of a nuclear holocaust is very important, because there's a huge quantity of nuclear weapons all over the world. And some people have evaluated the risk of about 1% per year, which means that over the next century, this might really happen. And so these are the kind of risk we have to take into account, with, of course, the risk of the global warming, which is happening at a slow pace, but which is happening. So these are really the problems that we have to face, and the government have to face these risks. And we have to live with that, and we have to take the measures that we can take for the risks that we know. Like now, I hope that we will have learned about the pandemic, and that when it will happen next time, the answer will be more rational. But we have to make sure that the other risks are also taken care of. And we live in a dangerous world, that's clear.
Thank you. Thank you for all your lovely questions. And I'm sorry that you have to wait a while to ask them, but we'll get to you. Tassia, please. You're on mute.
I'm sorry for that. It's a pleasure to chat to you today, Professor. And I'm Tassia, and I'm a PhD student in pharmaceutical science at the Federal University of Fenas, located in the state of Minas Gerais. And my question is, we already talked about how can we disclose the science for the society, how the government can face all of this crisis, but my question is more about the value of the science. So how do we know that we are on the path of producing a science of value? Is there any magic formula or strategic for that? I mean, how to develop our full potential to make it happen?
That's a difficult question. First of all, you have to ask yourself the right question, to understand that there is an issue at some point, that there's a question that you want to answer, and to try to find the ways to answer that. How do you find out whether you're on the good path or not? It then depends upon many factors. First of all, is what you are doing of interest for other people too? What you have to discuss with people, you have to communicate with people to make sure that the questions that you are asking yourself, other people are asking themselves too. And you have to of course, it's a risky business. If you are on an ambitious project, it means that it might fail, and you have to learn from your failures. You have to learn from the fact that you might be on a dead track, and that you have to change direction. I guess it's also in part a question of luck. You very often in a research career, you just find something that you did not expect, and 9 times out of 10, what you did not expect is just an artifact, not very important, but sometimes it's a surprise which leads to something really new. So you need some luck, but one of the quality of a researcher is that to be able to recognize when he stumbles on something which is new. And so you have to be able to take advantage of your luck, and that's also something important. But at the beginning, you have to be enthusiastic and to have a passion for what you are doing. So, and this passion is something which builds up very early in the career of a scientist, and very often it starts with when you are a child or a young student, and it's something which has to be nurtured and nourished by society, and it's why I think education is so important.
Thank you very much, Serge. Now I have 2 follow-ups for this one. I'll come to Daphne in a second, but first, William.
Hello, Professor. It's an honor to be here. My name is William. I'm a materials engineering student at the Federal University of Jequitinhonha and Mucuri Vales in Janaúba, Minas Gerais. And I'd like to ask you, following the question of our colleague, how do you see the impacts of the latest developments on quantum physics and physics in general in our developments in technology? What can we expect of technology in the future years, in your opinion?
Yeah, in quantum technology, you can expect progresses in quantum communication, the fact that you can use photons to communicate between people in a way which can be protected from spying. It's called quantum cryptography, and it's already working. You can also develop new tools, new probes of small magnetic or electric field, new clocks which measure time with a higher precision than before. And this could be useful for geodesic applications, for prediction of earthquakes, for instance. I often take the example of these optical clocks. Now, atomic clocks are now count the periods of electrons in atoms, and the standard clock now is a microwave clock, which counts 9 billion periods per second. But now we are developing new clocks which count the period of an optical transition, which is 5 orders of magnitude higher. And these 5 orders of magnitude translate into a 5 or 6 order of magnitude improvement in the precision of clocks. We have now clocks which have a precision of less than 1 second in the age of the universe. So it means that if 2 clocks had been synchronized 13 billion years ago, they would not deviate from one another by more than a fraction of a second. Such clocks would make it possible to develop a super GPS kind of system which would be sensitive to a change of time corresponding to a change in altitude of the clock of a few millimeters. And with this kind of precision, which is general relativity effect, you could make fantastic improvement in the survey of the Earth. For instance, see how the level of the water, the level of the oceans, or the width of the ice cap is changing with time. So you could study a lot of things, a lot of physical parameter with an increased precision. So communication, metrology, of course, there is a hope of a quantum computer verifying the future, quantum simulators. But again, I think maybe the most surprising application cannot be predicted. You know, there have been at the beginning of the 20th century, when the before quantum physics, when people have started with cinema and telephone and light bulbs, there was a big hope that the progress of science would be fantastic in the future. And people have been asked in 1900, what would be the life of people in the year 2000? And postcards were published everywhere in France, in Germany, in England. And what they predicted was ridiculous. Nobody had predicted the lasers, the computers, the atomic clock, the MRI, and so on. What people were doing was extrapolating better movies, better telephone systems. Even the airplane was not predicted. What they predicted is that transportation would be made by balloons and by, so it's very hard to predict the future, especially in technology. And what I can tell you today might be as ridiculous in 50 years from now. That's what I just said. That's the charm of research. You know, you find out things that you did not think about.
Thank you. Daphne.
Hello there, my name is Daphne Rosa. For me, it's an honor to be here. I'm an undergraduate student of mathematics in the Federal University of the Great Dourados, located in the state of Mato Grosso do Sul. And my question for you today, Professor Haroche, it's more of a follow-up as well. Whenever you are doing a research or questioning a theory, again, how do you know you are going to the right direction? But if you do not pursue it, the value of science will remain still for you.
What you mean is that can you learn from your failures? Can you learn from the fact that some things that you are doing are not successful? And this happens all the time. It's clear that if you have a theory which is not, have an idea which is not followed up by observation, and if what you observe differs from what the theory is predicted, you have to change it and you have to go in another direction. But what you learn from there can be useful, and this happened a lot of time in the history of sciences. For instance, what is light? The fact that the light is at the beginning, Newton believed that the light was a stream of particles. And then what has been discovered is that the light, in fact, was a wave, which gave rise to interference effects. And in the 19th century, people believed that light was made of waves and that the particle idea was ridiculous. And then at the beginning of the 20th century, Einstein came with the first idea about the quantum. And he came back to the idea that after all, light was also made of particles, and the photon came back into the picture. And then there was a kind of a mix between the particle and the wave aspect. And so it's, you know, how things evolve and how an idea which is supposed to be wrong at some point can come back in the forefront of science later on. So in fact, science is made of this kind of succession of hypotheses, ideas which might be found to be wrong at some point, and then which come back under another perspective. And well, here I am talking about the grand scale, about the history of science, but at the personal level, when you do research, the same thing may happen, that you do something which happen to be a dead alley and doesn't give result, but what you have done in between, you have learned, maybe you have learned some experimental skills, maybe you have learned some calculation skills, which will be helpful when you will go in another direction and find something which is closer to the truth. But the real truth is always escaping you, because there are always new ideas which come up, and the truth is evolving all the time. So you have to be, of course, at some point, it's good to be in the right direction. You cannot do always mistakes. You have at some point.
So let me throw in a quick follow-up from me. How do you know, as a young scientist, whether you're banging your head against the wall doing something that just is never going to work, or whether it's actually worth keeping going because there's something there if you could just find it?
I think it's very difficult to answer that question. You need to have a kind of intuition that what you are doing must be in the right direction, but you have also not, I think one part of the answer is that you have to try not to be always alone. You have to interact with people. You have to interact with colleagues, with students of the same generation as you, and you have to be lucky enough to have a good mentor and to have someone who can at least direct you, tell you whether he or she thinks that you are in the right track and give you some hints. So it's not, and it's less and less now an individual adventure. It's something which you share, and usually the research is made in a group, more or less small. Of course, if you think about the big projects, accelerator projects or astrophysical observatories, then it's huge group of thousands of people. But in my case, the research group is made of 10 to 20 people. Most of them are young postdoc and graduate students and a few colleagues. And one way to know whether you are on a good track or not is to discuss with your colleagues. Of course, you have to read the literature. You have to make sure that what you do is in the stream. Or if you do something really new, that it will interest other people. That's part of it. And you have also to go to meetings and to conferences and workshops. And now it's rather limited now, but I hope that next year the young scientists will be able to meet again and to discuss again together.
Okay, thank you. Lots of questions to get through. Jadson, please.
Hello, everyone. My name is Jadson. I am a mechanical engineering student at INSPER in the state of São Paulo. And my question for you, Professor Haroche, is how can we build a way to share research findings that don't involve paying so much money to scientific magazines?
You mean to publish your research? I think that's an important issue. You have to find. I think it's not normal that the scientific magazines charge a lot of money for the people who want to publish, and even not. It's not good also that they charge a lot of money to people who want to read and to access to literature. And I think that there are now a lot of efforts which are made for online access, free online access of published work. And this has started in physics, called the archives. For the last 20 years, you can just post your research on these archives for free and people can access them on the internet. I know it starts in biology too, but it does not solve all the problems because one important part of the publication is a peer review, the fact that the work has to be evaluated by peers. And so one have to find an equilibrium between free publication and the internet where anyone can post anything and the fact that the things has to be evaluated by peers. And I know that there is a lot of projects now try to combine these two points. And again, we come to the fact that the internet can be the best of things and the worst of things at the same time. You have to use the internet in a good and balanced way, and that's something which requires a lot of thought and a lot of attention.
Thank you very much indeed. Julia, please, Julia Rocha.
Thank you. It's an honor to be here. I am Julia. I'm a physics student at Federal University of Rio de Janeiro. And as a physics student, it is common to hear from different people outside this universe of science that science should always respond quickly and that more fundamental research does not impact society very much. As a scientist in a very fundamental field, have you ever had times when you doubted the importance of what you were doing?
What you say is right. A lot of people who don't understand what science is about say that science has to be useful, and they don't understand that usefulness is not just a short-term quality, that science becomes useful after a lot of years of fundamental research before that. And so there is a lot of things to be said about the usefulness of useless science. And many people have published papers or opinion pieces about that. In fact, for instance, the Institute of Advanced Physics in Princeton was funded by, in the 1930s, that's the place where Einstein has been appointed when he left Germany. This is a place where basic science has been advocated from the beginning. And the guy who founded this institute used to say that in fact, useless science is something which will lead to useful applications. And people have to understand that. And very often the governments everywhere, including in my country, have a tendency to dismiss basic science because it does not produce marketable ideas immediately, and they make a big mistake. If you just take as an example the development of vaccines now, the vaccines have been developed within 1 year, which is a tour de force, but this has been possible only because the last 20 years, a lot of research on messenger RNA, which was just basic science, were being done without the idea that it would apply to a pandemic that nobody had predicted. So again, this is another illustration of the fact that basic science is absolutely necessary, even if you consider that science has in the end to be useful. But it goes even beyond that, because there is a lot of science which will never be useful. It's clear that what people are doing to find out exoplanets or to find out whether there is life somewhere else in the universe doesn't have any direct usefulness. So we'll never go there, we'll never interact with other civilization, but still it is something that mankind has to know because it's part of our civilization. We have to build knowledge even if it's not useful. And but this is very hard to make people understand. I just give you some arguments that you can use when you discuss with people who tell you that, and think it's a big problem that we have to face, of course.
Thank you. Patricia.
Thank you very much for this opportunity. My name is Patricia Mia Suzuki. I'm from Pará State. I'm forest engineering student at Federal Rural University of Amazon. Well, sometimes scientific results can be very complicated to know sciences people understood. As a result of this, the engagement of those people can be very difficult. In your opinion, how may we bring science closer to people? And I'm curious, if you have some activity in your local community, in this way, explain about your studies and yes, thank you very much.
Yeah, what I'm trying to do is to, as often as I can, is to give lectures or talks to students. It goes, I did that sometimes with elementary school students, most often with middle school and high school students. And I try to convey to them the excitement of science, the passion for science, the fact that asking big questions is very rewarding. Also, I try to tell them that it's demanding. Science is not a game. It's something which requires knowledge, which requires a lot of ability to, especially in the kind of in the case of physics, an ability to do mathematics, to compute, to solve equations. But I always try to show that behind the mathematical and the technicity of science, there are some big ideas which have to be put forward, and I give examples coming from history. So I try to do that, and I know that there are a lot of teachers who try to do that. There are a lot of programs which are called hand-on programs, in which you try to teach to young students, to young children, experimental skills, to show them that you can do simple chemistry or simple electricity experiments with very simple kits. And the kits, and you can also observe the stars and observe the planets with very basic telescopes, and all these kind of programs are very useful to tell children that science is fun and science is fascinating. And we need also to convey that to grown-ups, because after all, these are the people who basically fund science. If you want to have a society which will give money to scientists, I think the people have to understand that science is useful and valuable. And so I try to explain that, and to say that I try to explain to people in countries, especially like Brazil, that the main wealth of a country is in the mind of the young people. And you give a perfect example of that. You have to nurture the spirit of young people for science and for knowledge, because this is certainly what is required for the future of a country, not only in Brazil, but everywhere. And even the countries which have natural resources, in the end, the power will come from the brain of the people, because the resources will last only the time they last, but you have to be prepared for the challenges that we are going to face. And for that, you need to bring more and more people towards scientific careers, engineering and science, and fundamental science and applied sciences.
I believe we have two follow-up questions there from Leandro, but also João Marcos. So João Marcos first, please, if I'm saying it right.
Thank you. I'm João Marcos, currently doing my master in physics at Federal University of Tocantins. It's a great honor to be a part of this incredible event. So when it's coming to develop scientific research, the scientists must prove that science itself has its value, which demands lots of hard work and full time. Generally, financial investment for research funding is extremely precarious, and the returns take too long. Some types of research can take decades to develop the first results. Even with so little, science today is remarkably advanced, and every day it's developed even more. That being said, what would you say to a person who is still at the beginning of his scientific career?
I think the question you are addressing should be the person who need an advice about that are the people who give money for science. And they should be asked to give more money for science, taking into account all what we discussed and said up to now. Now, about a young researcher, first of all, I think it's very useful, if possible, after a PhD, to go for a postdoc abroad, to be able to try to learn new things, to change one's environment, to find new ways of thinking and new ways of doing research. And that's what I did, and that's what I recommend to my students to do that. But of course, after that, the question is, when they come back to their country, in this case to Brazil, what kind of position they will get, and how they will be sustained and supported in doing their research. And I understand that it's a difficult time now. In fact, not only in Brazil, it's also a difficult time in France, because the funding for research is not at the level it should be. What I can say is that some of you, and as it happened in France, some of you might stay abroad. And I know many very good scientists from South America, Brazil, Argentina, and other countries who have had their careers in the United States or in Europe because they did not find a way to be able to fulfill their ambition in South America. But I know I have also colleagues who came back to Brazil and who struggled and fought in order to be able to do things in this country, and it has been successful. There have been a period at the beginning of the years 2000, from 2000 to 2010, when the funding in Brazil was quite adequate and comparable to what it is in Europe. And I can only hope that this will happen again in the not too distant future in Brazil. I think what the politicians have to understand is that it's very easy to, it takes a long time to build up a good scientific environment, but it takes a very short time to destroy it, because if you only lose one generation of students, which is just 5 or 6 years, then you have broken the chain of science, and between generations it's very hard to build it up again. So I really hope that the situation will improve in Brazil, and that the funding for science will resume. And it's not only in Brazil. I have been involved also in this kind of discussion in other countries like Colombia and Argentina, and it's the same there. And I think it's very important, because as you are the living proof that there is a lot of very bright young people in all these countries. And as I said, this is the future of these countries. You have very big issues, very big challenges at stake. And the challenges not only for Brazil. It's clear that the challenges that you are facing will have an impact on the development of the planet as a whole, because it's, South America is a very big continent, and you have resources there which are useful for the rest of mankind. So that's what I can say about that. I think this question should be addressed to politicians and to statesmen and women. They have to understand the issues of science. That's the basic point.
Thank you, Serge. We don't have very long left, and I would really like people to get the chance to speak. So if questions can be short, and Serge, if your answers can be very short, that's also great. Leandro, I was going to come to you next, sorry.
All right. So I am Leandro Nola Eduardo, PhD student of Marine Science in the University Federal Rural de Pernambuco. And my question is something similar. I believe that to build a strong scientific community in Brazil, we need not only produce good scientists, but also keep them in the country. However, as a scientist, I feel that I may have better opportunities abroad. So my question is, thinking about the country and the science, do you believe that it's better if we stay in the country and fight for the science of our nation, even if it means working in not perfect conditions, or it doesn't matter? If I go in the best play we can, eventually I will end up contributing to science and to my country.
I think it's a very I would repent by yes or no. It's a very personal question. I face the same question from students in France. They are very bright students who decide to go abroad because they have much better working conditions abroad, and I cannot blame them. I think if you are ambitious and if your passion is science, you cannot be blamed for choosing the place where you will be able to provide the best solutions and get the best of science that you can do. There, in this, I can take a few examples of there have been Nobel Prizes from Mexico, Argentina, and of people who went abroad and did fantastic research and even got a Nobel Prize. This year, there was a French woman who got a Nobel Prize in medicine, and she's working in Germany because she found in Germany better conditions than in France. And I cannot blame her for that. I think science is universal. Science has no boundaries. And so if you find a good position elsewhere and are happy about that, it's good. Now, of course, if you think that you can bring to Brazil your knowledge and your skills, and that's important for you, of course, it's fantastic too. And as I said, I have examples of very close friends and good scientists who went to United States at the time of the generals in Brazil during the dictatorship. And when the democracy came back to Brazil, they came back and they were able to build science centers in various places in Brazil. And I'm sure that they got from this a lot of satisfaction, a lot of pleasure, because it was useful for their community and for their country.
Thank you, Serge. Rodrigo, you had a follow-up.
Good afternoon. I'm Rodrigo Libera from University of Paraíba, and I study agroecology. I think you were discussing about denialism and access to people to science. I think science often comes into people's lives packaged inside the market format. So medicine or a new seed in my field, agriculture, a new genetic modified seed. What we are seeing is that we're losing a lot of traditional knowledge in science with herbal plants and in genetics that took tens of thousands of years to develop crop seeds that we can eat today, and favoring patented options by big corporations. I think this creates a detachment from people, from day-to-day lives in science, and denialism ultimately. So how do we make sure that science is not only seen by people with this market phase, but can dialogue with day-to-day and traditional technology and knowledge that took millennia to build?
It is hard to answer by to give a very short answer to this question, but it's I think maybe I am not a specialist, of course, in agriculture and if genetically modified organism, but what I would say is that what people have been doing over thousands of years is to do genetically modified organism, but over a long period of time. When you domesticate animals or plants, you modify them progressively, and maybe one has to make people, the general public, understand that there is no contradiction between traditional ways of doing things and the fact that modern science can allow you to do things in a more rational way and faster without losing all the expertise and all the knowledge which has been brought by traditional sciences. I'm not working in this field, but I can take as an example this Chinese woman who got a Nobel Prize because she used a very old method for, she developed in a modern setting what the Chinese medicine had learned to get medicine for
malaria.
Disease, for malaria, for instance. And so there is a connection. I think modern science and traditional science should develop together. And that's the only way to avoid this idea that there are conspiracy theories that the genetically modified organisms are just a plot from the big companies to poison our agriculture. And you have to understand that modern science can be useful in medicine, in agriculture, but it does not have to just forget what tradition have, the kind of knowledge which come from a very long time, for a long history, as you said. I think it should go together.
Thank you very much indeed. Serge, now I'm aware that we're overrunning, but there are three people, I think three, who have not asked a question yet, and I'd really like, or maybe four, and I'd really like them to get to ask their questions. So let's keep the questions and answers really short, and thank you for the audience for staying with us. Okay, Daniel Suarez, you go first.
Hi everyone, my name is Daniel Oscar. I'm studying agriculture at the Federal University of Amazonas. And my question today is about sustainable development. So we all know that we need to preserve the forests, we need to preserve our biodiversity, we need to preserve our planet for the next generation. So what is the role, what is the importance of science for sustainable development? Thank you.
I'm sure you know much more than I do about this field. But of course, science first is important because science can collect data. I think science is important because it tells you where are the problems. For example, how much of the forest is being destroyed every year, how much of what is the effect of this on the level of CO2 in the atmosphere, what is to measure the impact on the climate and on the biodiversity. So first it's observation. And also after that, science has been used to try to find a solution to what has been observed, which is new technologies, new ways to raise crops, new techniques to gather energy without producing CO2 and so on. So it's again, it's the same combination of observation and experiments and technology, which everything going together. But at the first level, science has to produce facts which are not fake news, which is very different. And of course, you know all this.
Thank you. And next, thank you for the question. Next over to Rui Aquino.
Thank you for the opportunity. Professor, I would like to ask you, what drives you to research? What keeps you motivated through the good and the bad days to keep working to do high quality research?
Okay, that's what drove me is the passion for new knowledge, the fact that I understood that I was, by the kind of research I was doing, I was part of a general trend towards trying to get, to increase the knowledge about nature, to increase knowledge about the physical laws, and that this knowledge would one day be useful for something, even if I did not know what it would be useful for. But I derived a lot of pleasure and a lot of excitement from the fact that I could discover new things. In fact, for instance, I worked in the domain of interaction of atoms with photons, and I was able to build systems in which one atom was interacting with one photon. And this led to the observation of quantum effects, which were known before, but had never been observed under these simple and very straightforward conditions. And this is exciting by itself. When you observe something that nobody has observed before, even if it does not give any direct application, it's very thrilling. And so the excitement comes from that, from the fact that you challenge yourself, and that sometimes the challenge is successful and you observe what you thought you would observe, or you observe something new. It's a little bit like the challenge that an alpinist has. He just climbed the mountain because the mountain is there, and we try to find new things because there are things behind the horizon and we want to understand things better. It's very difficult to define that more precisely.
Thank you, but that was a beautiful answer. Victor Hugo, please.
Hey, good afternoon, Mr. Haroche. My name is Victor Hugo. I'm a law student at Federal University of Paraná, located in the capital of the state, Curitiba. And I'm also a human rights researcher and defensor. And I would like to follow the lead of one of my colleagues and go back to the humanities. To give some examples of the many difficulties that the sciences are facing in Brazil, like she has mentioned, we have reduced the workload of the disciplines of philosophy and sociology in schools, and they're probably going to become optional disciplines thanks to the high school reform that took place during the government of the former president Michel Temer in 2017. In addition, the humanities area was excluded from federal scholarships of scientific initiations in 2020 under the actual Bolsonaro government. Is there a similar scenario of devaluation of the humanities in the countries where you've taught? And do you see any practical way to transform it?
I think there is a trend like that, and even in the United States, I think the humanities are going through a very difficult time now, and I think it's wrong, as I told you, but I think it might also due to the fact that people are afraid that humanities are too much linked toward politics and political issues, and of course this displeases some people. And I think it's wrong because, as I said, you cannot develop a society if you don't develop the idea of free thinking and free creative thinking, and humanities are essential for that. You have to read literature, you have to read philosophers, you have to know the history of ideas and in the past and today if you want to have an open mind and be ready to work even in science. So I just think we have to lobby for that with the political people, and it's clear that the point is that you have to make sure that the students who go into these fields will find the positions, will find jobs after that. So you have to make sure that these fields are open for jobs in society. And I think there are a lot of jobs which are important. Social issues, psychological issues are very important. The way people will respond in the future to the big challenges we have to face, the fact that we have to change our way of living if we want to sustain life on the planet will require an understanding of how people will react to that, how people will adjust to these big changes. And for that, we need sociologists, we need psychologists, we need humanities in general.
Thank you very much indeed, Serge. And then final question to Pedro.
Thanks, Adam. Just a unique moment being here. I'm Pedro Henrique Peixoto, an undergraduate student in mathematics in the Federal University of Goiás. As you mentioned during this panel, we do know that science has proved its importance for building a society based on education. Coming from developing country as you, Professor Serge, in your point of view, from where it comes the willingness of being a scientist, and how much of this comes from elementary education, taking into account that the most amazing questions come from these students? Thank you in advance.
Yes, it's a good question. In fact, in my case, I was attracted to science when I was a child because I loved maths. I like to compute things. I like to count, to classify objects. I remember I classified the metals from the lightest to the heaviest one. I classified the planets according to their size, their mass, escape velocity from their surface, and so on. So I was a kind of maniac of classification, and I understood that's what in my genes, I guess. And I was also fascinated by astronomy, by the fact that you can, by observing the planets and the stars, you discover that they obey to mathematical laws. And this adequacy between mathematics and physics was something which fascinated me and which kept surprising me all the time. As you know, certainly quantum physics is based on mathematical theories, very simple one for a mathematician, but still you have a lot of math built up into quantum physics. And the fact that the world obeys to equations is something which is really fascinating. And one of the first one to recognize that was Galileo 4 centuries ago. And I think you can instill that in the mind of children, because I think it's a fascinating, it's a very mysterious and fascinating idea. And but for that, you need good teachers who are good in math first, which is not very often the case. What I think is very bad that in elementary schools, the teachers very often have only kind of literary training, but know very few things about math. And if you want to teach math even to young children, you need to be able to see the field from above and not be just in very simple calculation. For that, you need teachers who can give you this feeling of amazement. And that brings me back to what I said in the previous session, that if you need really good teachers for young people, and for that you need to pay them well, and you need teachers to be recognized as very useful, essential for the development of a country and a society. So if it was the last question, I want to thank you all. I was really amazed by, first of all, by your level in English, which I found remarkable, and by the fact that you are so interested by such important issues. And this, usually I'm a rather pessimistic person about the future of the planet, but listening to you, I am more optimistic now, because the future is in your hands. So, and this is true in Brazil, and it's true elsewhere too. And I want to wish you good luck, whatever you do. I know it will not be easy, but we have to do it. And I trust that you will be able to achieve very important things in the future. Thank you very much.
Thank you so much, Serge, for those lovely words. And let me just second that the opportunity to listen to these extraordinary people from all over Brazil, and also my Brits' absolutely infectious optimism from earlier, is a combination to leave us all feeling very hopeful. So just let me second Serge's thanks to you all for taking the time to be here and for your wonderful questions and for your eloquence. I also need to thank you, Serge, for your lovely answers and for taking so many questions in such a short time. That's wonderful.
I hope we will meet next year in person in Brazil.
Exactly. So when we organize the real Nobel Prize Dialogue in Rio and Sao Paulo, I hope you'll all be there. Let's hope it's possible. Let's hope the situation somehow improves quickly. And I'd also like to just give some words of thanks to the audience who have been watching, and some dedicated audience members will still be with us, and to them I congratulate you for and thank you for your presence, and also I hope you've enjoyed it very much indeed.
And take care of yourself, all of you, because I know you are in a very dangerous situation.
Well said. Well said. Thank you all. Thank you for listening. Goodbye.